Good morning, dear students. Welcome to science class. As we are discussing chapter number 11, work and energy. In previous class, we have discussed about the work and the positive and negative work. Today, we are going to discuss about the energy and the types of energy. Energy is the capacity of doing work. Any object having capability to do work is said to possess energy. Right? So energy are of two types. One is kinetic energy and another is the potential energy. So kinetic energy is the energy possessed by the motion. The energy possessed by the motion is called the kinetic energy, or the energy possessed by the moving object is called the kinetic energy, as flowing of water have lots of energy, right? So that energy is called the kinetic energy of water. For example, blowing wind has motion, so blowing wind possesses kinetic energy, which may be used to run windmills. And a falling apple or coconut, a moving stone, a moving ball, all they possess kinetic energy because of they are in motion and they have energy, right? So first we will discuss the derivation or the expression for kinetic energy. What are their expression and how they derived? So the formula for kinetic energy is denoted by Ek equals to half mv square. Now suppose that a moving object possesses kinetic energy due to its motion, right? So as the definition I told you, the kinetic energy of an object moving with a certain velocity is equal to the work done on it to make it acquire that velocity. Suppose an object of mass m lying at rest on a smooth level surface, and let a constant force F be applied on the object so that it attains a velocity of v after covering a displacement that is small s, right? And in the direction of force. So here in the picture you can see, so the work done will be, that is, if force is applying and displacement will be s, then the work done will be W equals to Fs, right? And the object is initially at rest, so we take U equals to 0, that is the initial velocity, and V will be the final velocity, right? So according to the equation of motion, the third equation of motion, we have V square minus U square equals to 2s, right? And if we put 0 in place of U, we get acceleration will equal to V square by 2s. Now we get acceleration, and in accordance with Newton's second law of motion, force is equals to mass into acceleration, right? And we put the value of acceleration in that place of A, so we get mv square by 2s. So from here we get that work done will be equals to half mv square, and by the definition the work done is equals to the kinetic energy acquired by the moving object. So here comes kinetic energy denoted by Ek equals to half mv square, right? So this is the expression for kinetic energy. Now next is potential energy. Potential energy is the energy possessed by the virtue of their position, right? Means in which position it is placing. So the energy possessed by an object by virtue of its position or configuration is called its potential energy. For example, a stone lying on the ground at rest, it cannot do any cannot do any work by itself. Lift the stone to the roof of the house. Obviously, some work has been done on the stone in lifting it against the force of gravity, and this work done is stored up in the stone as its potential energy, right? So if the stone is released, it begins to fall. It shows that stone has acquired some energy due to change in its position, right? So now we will take another example, like take a rubber band, hold it in one hand and pull from the other hand. The band is stretched. Now release the band. The band tends to regain its original size. Obviously, the band had acquired energy in its stretched position on account of change in its size. So in this way, the band acquired some potential energy, right? So work done on an object is transferred into energy. This energy transferred to the object is stored as its potential energy, the energy by its position. Now we will see the derivation of potential energy. What is the formula of potential energy? EP, P is denoting for potential energy, is equals to mgh. So let us consider an object of mass small m and let it be raised through a height capital H from the ground. A force is required to raise the object, and the minimum amount of force required against the gravity is equals to the weight of the object. So force again is equals to the mg. Here we are taking g because it is acceleration due to gravity. Work done is equals to force into displacement, right? So force and displacement is denoted by h. So F into H. F, put the value of F here, that is F equals to mg. So it will be mg into H. mgh. mgh is the potential energy. So this work done on the object is stored in it in the form of its gravitational potential energy. Hence potential energy of an object is its position A at an height h above the ground will be equals to EP equals to mgh.